Yes.
Thank you, Casper. Welcome all to this session. We will have the pleasure to welcome Mieke de Ketelaere for Keynote, that is drivers for success in AI. And I'm sure you will talk us about your new book, Mieke. So Mieke, you are the program director AI at IMEC. You hold a master degree in civil and industrial engineering and specialize in robotics and artificial intelligence. Over the last 25 years, you have worked for several multinational on all aspects of data and analytics by IBM, Microsoft, SAP, SAS, SAS. At IMEC, Mieke, you are responsible for the development of the AI strategy and rollout. From a consulting point of view, you are specialized in defining the AI business canvas from potential value to predefined risks. With your understanding of the new digital data streams and your understanding of AI technologies, Mieke, you are requested by different business schools as guest speaker on digitalization. And in your public presentation, you put the focus on the demystification of the hype around AI and cover non-technical subjects such as data privacy. In 2018, you were nominated ICT Woman of the Year in Belgium, and you are also a member of the AI for Belgium Advisory Board. Thank you, Mieke, for this keynote, and the floor is yours.
Thank you so much, Nathaniel. Thanks for giving me this time to present my book, because it's more a book presentation than what I call a keynote.
Yeah.
I will have time for questions at the end. For me, the debate and the collaboration and understanding the open questions are as important as sharing slides. Slides will be delivered also afterwards. Feel free to use them. That's the way the reason why I create them. So let's go ahead with the presentation. I will start with sharing my screen. If all is fine, you should see my screen right now in presentation modus. Can you confirm, please?
Yes.
Okay, perfect. So maybe first of all, why did I write a book on AI, on a topic that's so controversial? In fact, the book was launched last year, November, and in the meantime, I'm also happy to announce that it's going to be in French and in English available on the market in Q2 this year, so most likely in May. So, but why did I write it? And I'm going to make this, because it's a Thursday night, I'm going to make this a little personal story. It actually wasn't my initial idea. I was going to write a book about women in business and how to survive that over the last 25 years. But then Pelkmans told me, but Mieke, why don't you write a book on AI first? And I remember going home from that meeting and saying, but why should I write a book about AI? I mean, there's so many books out there. I'm in it all the time. There are no open questions. So I asked Pelkmans to give me some time to think. And so that's how I started. I took time to think, and I started reading, the numbers that were out there, understanding, the play field we got into after so many years of AI, understanding the Belgian ranking, understanding why we are where we were. Also understanding the adoption ratio over the last years. I noticed that, we were sort of stuck on 17%, and that wasn't really increasing over the last years, although the number of investments hadn't gone up. So I started realizing that some things weren't well qualified or were well clarified out there, why budgets were maybe not correctly spent. Additionally, I started seeing that businesses were implementing AI, but were creating solutions that were sort of misbehaving. Misbehaving meaning that they were creating decisions that were incorrectly, that were adapted to the context where they were supposed to be in. And so I thought, well, there's something going on that we haven't really understood. And what was going on is that there was a lost in translation between the people that are creating the systems and the external world that haven't really completely understood how it all works together. So when I started then looking externally and I started going into discussions with people in the market or on business level, or even citizens, I noticed a lot of confusion. Now, every slide in my slide deck today, I can easily talk for 2 hours about it, but which of course I don't have the time right now, but basically in a nutshell, business confusion was on the fact that people were quickly saying, well, I have hired a data scientist, Mieke, I'm all set. Or Mieke, I have data, there must be something in there. Where I'm like, no, that's not how it works. Or I went to, to the citizens, and there I saw some people that were scared. They were thinking about, AI as being a Terminator. And I'm like, well, no, that's not what it is. That's, science fiction. Same questions on government. When I was sitting in a debate and one of the people asked to the government, but if AI does something wrong, whose fault is it? There was a straight answer, that's the engineer. I'm like, no, it's not the engineer. It's something we should all be together responsible for. We should have a multidisciplinary debate about it. And so I saw all these confusion. I'm like, well, let me go back to Peltmans and let me write that book, because I can only be part of a huge puzzle, but let me make sure that that translation that got lost between technical people and the outside world, that gets a little bit at least solved. That was the reason for writing the book. Now, for me, as Nathaniel already explained it, I was able to use and jump on the second hype. So in 88, when I started my studies, finishing my degree in 92, where we were sort of competing with the internet. It's also the moment where I left AI a little bit behind and jumped on the digitalization track, going through the Silicon Valley startups, etc. Arriving about 10, 15 years ago, again, back into my zone of comfort, which was AI. Now, if I look at it where we are today, of course, I observe the great value that we see in solutions. I observe the explosive growth, but I also observe attention out there. I observe attention between believers, one side from a business point of view, and the non-believers. I also see an enormous amount of people that don't care, that sort of have a complexity bias when I start talking about it, who want to use technology, but they don't want to really know how it works. And this is why I think that some explainability or some explanations are needed. Because if we were going to use technology, we all need to take the accountability to get some understanding of it at a certain level. We all use microwaves. We also know the limitations of microwaves and how to use them. Well, that's the same with the autonomous systems we're using. We should take our own responsibility, each of us, to understand to a certain level how it works. Now, how it works is where it actually got a little bit wrong. And don't get me, don't understand me incorrectly. When I say it got wrong, it's just that there was a lost in translation, as I mentioned before, because AI is no longer just about data and technology. It's about people, it's about processes, it's about having impact on decisions on people, so sociology. It's about citizen size, understanding the needs from the citizens. When are citizens going to accept certain autonomous solutions, when not? It's about business. So there's many people involved. And I think this is where we need to make an extra effort in the next years. We need to find the right language to translate each domain into what it means to the other domains. So it needs an effort from all of us implicated in AI to make sure that the other person on the table understands what our vision is. If it's from a legal perspective, legal terms, technology terms, or sociology terms, all of us need to make a little effort to make sure that as a team, we move on forwards and we create solutions that create the value as they can do, but take away and remove away the stress and the tension that's out there and the lack of trust. That's the responsibility we need to take as a multidisciplinary team. And that's why I like the ecosystem of AI for Belgium, which is doing a fantastic job at this level. Now, I could easily fill, working at IMEC, I could easily fill a complete hour with the fantastic creations and solutions we're building in the area of smart solutions, smart construction, smart health, smart mobility, etc. But for me, that's too easy. To me, it's bringing use cases is very valuable for an inspirational point of view. However, to me, it's like going to Disneyland, where you see an attraction, you use it once, and then you move on to the next attraction. For me, I've always been interested also as a child to look behind the scenes, to see how these attractions are built, what the dangers are of the attractions, what the limitations are of the attractions, etc. Because after all, next to these great cases that we see on a daily basis in the press, we also see information just as these ones. These are press releases that were coming from the last 3 months. So I didn't take information from 5 years ago in a fast moving world like AI. I took information from companies that are quite big, IBM, Uber, Google, that mentioned something in the press about limitations they have seen using the technology. Is it from an ethical side, from a technology side, or from a moral side? There have been many messages out there that actually strengthen this, the stress that is coming up in order to improve the adoption. Because don't forget, this is all about making sure we can increase the adoption within an environment that creates trust. So when you see these press releases and you ask around from why is this happening, you see that people are unable to divide between this is because the limitation of the technology itself, this is because of a human error, or this is because there's no framework out there that allows these technologies to be installed in a correct way. So this is what I'd also wanted to tackle. So that means that I'm going to take you now in my session behind the scenes of Disneyland AI. I'm going to look with you at the issues around privacy, liability, errors, limitations that we have, etc. With the purpose, the main purpose, to make sure we get a good translation out there, and in order to make sure we can increase the adoption. That's my ultimate point. So it's not focusing on the negative parts, it's removing away the negative parts, making them understandable, making sure we get them solved, these questions, in order to increase the adoption towards the future. If you look at AI, as I've mentioned before, it is no longer about data and technology. AI has moved into our common in our world. It's moved out of being just a pure academic science into a world where we now live in the middle of our autonomous systems. That means they have implication on people and also on processes around us. They need to be well installed in the processes that we have in order to bring the value that they can have. While doing so, there's only two limits that we need to take into account when we create technology, and that's for all technology. That's also for our cars, etc. We shouldn't go into the ecological ceiling. Ecological ceiling is basically the limitation that nature gives us while we're living on this planet. We should also, from the other side, don't tackle the social foundations we've been building over the last couple of years or centuries. At the moment, it means that what we see in the solutions we're building, if you look at them more carefully, we see a lot of solutions that are quite neat between those barriers. However, we see solutions that actually start to tackle social foundations we've built. These are the ones that we need to solve. And we see usage of AI where the energy efficiency isn't very acceptable anymore. Definitely not when we look at it from a sustainable point of view. So it's touching the ecological ceiling. This, of course, is no longer acceptable. So we need to make sure that the solutions we're building are going to be, again, within the barriers of our technology. If we do so, I'm sure that humans and citizens and companies will embrace technology much more. This view is, by the way, based on the Donut Economics, a book you probably know. Now, moving forwards in my session, let us now go into the 3 different areas. So I call them the good, the bad, and the ugly. The good ones are the areas where AI is probably just having a limitation because the way it is, because the reason of how it's built. AI is imitating human intelligence. However, it works in a slightly different way as we speak today. The maturity level of AI isn't always at the same level as we have our human intelligence. That's what I call the good ones, because it's just the limitation of the technology that we should accept, and somehow that got lost in translation. The bad ones are the ones that where AI is making mistakes. However, the mistakes are triggered by human mistakes, by not understanding very well how the technology works. So we will look in some example of those. And then last one is the ugly ones. The ugly ones are the examples where AI is creating challenging situations, but because the fact it got in the hands of the wrong people, which means there is not yet a framework out there which protects us from this to happen. We will look into the examples. Let's first start with the good ones. Now, the good ones, I take you back to the original idea, which was also mentioned this morning by Luc Steels, is that the original idea of the academic discipline AI was to make a copy or try to make in an artificial way human intelligence, to build it in an artificial way. And it was a mathematical domain where we're looking into formulas, algorithms, etc. And it was basically the dark blue box, as you see it here on the slide. Now, this got over time, this got extended into systems that we now call automated decisioning system, where straight from the sensors, just like we have the human sensors in our cells, in our human body, it was going straight into in pre-processing mode. It goes into the algorithms make a decision, the decision is translated into certain actors, just like our human body does. If we see something, we can decide, or our brain can decide to go and run. So this is what we've been building over the last couple of years, and now creating in automated decisioning systems, forgetting sometimes that AI is the kernel in there, which is the brain. Now, as mentioned, this is my book is written to a very broad audience. This is the way I explain it. I understand I'm making some shortcuts here, but basically the principal steps of an AI system, as we call it today, because on AI we can have a huge discussion on the definition, but the way AI is now called in the media is mainly referring to this, having sensors that take information, pre-process it, analyze it automatically, see some patterns in it automatically, put a decision out there, and then send that decision to an actioner that can take the needed action. So if you know this in mind, if you keep this image in mind, we can now look at the current limitations of it. The current limitations of the way artificial intelligence works. Now, I can take a lot of time on this, but I've just put it into a graph, which you will also find in my book. And we could just say that in 2021, we could say that AI has a tremendous amount of intelligence when it gets to the speed of processing, the ability to transfer knowledge, basically the fact that we can copy an algorithm into another algorithm, which we can't do with our brain. I cannot copy my brain, download it, and upload it somewhere else. Decision accuracy on big data is much better than human intelligence. I think we all have to agree. We also know the reasons. This is because an AI system can look at many more examples, for example, on skin cancer than what a human can do in his life. So this is where artificial intelligence wins. Also the fact that we still need to sleep from time to time in order to make sure that our brain is up and running again the next day. Well, AI, as long as it's empowered by energy and by electricity or battery, it will continue to run. So this is where AI wins at this point in time. So where is a human intelligence still winning? Well, it wins on a couple of points. First of all, if you look at our brain and we compare to the big cloud environments where some smart decisioning is made, well, we can say that the size of storage, well, human intelligence is still doing it better. Also, our energy usage, if you dive into how much energy we are consuming, when we're making a decision, it's much lower than the way AI does it at the moment. Also, the fact that we can do a parallel processing, I can in the meantime listen with my ears and speak out with my mouth and see things. In fact, we can, from nature, as a baby already, we can do parallel processing, while AI, we will see it in examples, is still struggling. And like this, we have a very, very long list, which was also mentioned by Alexander De Croo in the session this morning on topics such as creativity, emotions, human dialogue. So although we've evolved quite a lot with our recent language models, we still have to say that on human dialogues, human intelligence is still winning. And of course, ethical, so the bias, the unconscious bias, this is where we are equal. I mean, human intelligence, our brain has, is behaving like we have been trained in the past, and as a child, we actually unbiased, and some people don't always realize, but the bias gets into the human brain at the age of 6, well, this decisions we've made in the past is now being entered into artificial intelligence's domain, which is very much tackled and already was shown a couple of times this week as an important attention point. So, but this is sort of, the status where we are in 2021. That means that from a research perspective, what we're trying to do, we're trying to move these boxes from the left side to the right side, one by one, in order to make sure we are going to improve in, in maturity. Now, to go dive into a little bit deeper what it actually means, and to also show what, from a research perspective at IMEC, what we're doing, let me take out a couple of examples. From an energy consumption point of view, it's something that isn't observed or not tackled very well, is that training huge AI systems, or even training AI system overall, is consuming quite a lot of energy. So the CO2 emission, there are calculators online. You can test for your own algorithms to see how much CO2 emission is caused by your algorithm. Now, it is difficult to compare apples with apples and to put a fixed number on this, because it depends on the cloud environment you're using, this type of hardware you're using, the type of algorithms you're using. But basically, you can say that the total energy is the energy that's being used to train the brain, the artificial brain. And each time you're going to call up that brain to make a decision, so it's during inference, the energy consumption goes up. On top of that, we are still working with a very much centralized environments where we are taking data, and at the end, where the sensors are, we're sending it to a central environment or cloud environment. So also the data transfer we're doing is costing us energy. So I've put a formula out there. That's also the most difficult formula that's in my slide deck, to show you that having an understanding of the fact that if we use our digital systems and our autonomous systems, we should also be smart thinking about it, about the CO2 emission we're doing. Sometimes leaving on the light is less expensive from a CO2 emission than asking Siri to switch on and switch off a light. We need to think about this. Now, what can you do about it? Before we look into this, we need to understand where it comes from. I have put a picture out here. What you see in the middle is a Volkswagen bus. And you might say, well, what's this doing there? Well, there's a personal story behind it. When I did my thesis, I understood back then in '92 that there was a direct relation between the size of the computer I was going to have for my algorithm, for my neural net, and the accuracy that my model would have. And I had a dream of traveling worldwide and just starting to PhD in neural nets. So I knew that the bigger the computer I can get access to, the better my thesis will be, the more points I'm going to get, and the more likely I'm going to be accepted for a PhD. So I started working day and night in order to get myself the biggest computer I could have. My computer back then was, training itself for 3.5 days, something that would just be in a millisecond right now. And so that's the time where you see the Volkswagen bus, where I was able from Stuttgart, where I did my studies, to go and windsurf in Lago di Garda while my algorithm was training. Because I realized, okay, if I get this big system, I'm going to be able to use more data to train it, and my model can be bigger, the number of neurons are going to be increased. My performance is going to be better, and I will get more money, or in my case, I would get a better position to do a doctorate degree. This very simple graph shows you exactly what happens in the last 25 years. In the last 25 years, there's been a battle between companies understanding exactly this same circle. As soon as they found out that there was a direct relationship between, having more data, customer data, for example, for Google or Amazon, being able to create bigger models, having a better performance, having more people investing into the company, getting with this money, being able to get more data, bigger models, etc. This is actually what happened and where we are right now, because the reason was that from a research point of view and also from an investment point of view, everything was focused on accuracy of the decisions that the systems could make. This, of course, is no longer in line with the focus now on energy consumption, because with the size of the models, also the energy consumption increased tremendously. And this is the slide we saw before. So what we see since 2 years is that next to accuracy, now also energy efficiency becomes a key KPI in the models and in the systems we're building. And how do we do this? Well, there's different ways to do so from a research point of view and also from a commercial point of view. You see these things happening more and more now also in commercial point of view. First of all, there's a lot of work to do on hardware. We've moved from the typical CPUs to GPUs to TPUs, and this will continue to find out more like which new materials we can use, new architectures, etc. Because computers back then weren't made for AI. AI just works differently from standard transactional system. Secondly, we're going to get ourselves inspired by nature on looking how is it possible that we can learn new things while using or while consuming so less energy. And then we see that we naturally from our nature, we do things like transfer learning. If we know how to play tennis, we have it easier to quickly adopt to play squash, for example, because we transfer the knowledge we got from one domain into another domain. Well, exactly the same principle we can do in our AI system. Instead of building your models from scratch, from zero, try to find models out there that have already in a similar area, for example, image recognition, trained itself and take the first layers like we do from when we switch from squash to tennis or from tennis to squash. Just transfer learning is a very upcoming domain to do more energy efficient work in AI. Additionally, nature automatically disconnects in, for example, the trees, the branches that don't bring any value to the tree. Well, it's the same with our AI. If we look at neural nets, at the end, we can always find out that there are branches in that neural net that don't bring any value or very, very limited value to the end results. Well, why not cutting these branches out? Because every branch, every neuron that needs to calculate, it's a calculation, it consumes energy. So right now, what we do is, again, inspired by nature, we use this technique, we call this network pruning, just like nature does it and shows it how to decrease on the number of energy. Similar to our environments, at the moment, as mentioned, we are working in a very centralized way. We capture data on the end points, we send it over to a central environment, we crunch it there, and we send back the action. This has a couple of limitations. It's limiting the latency possibilities. It's limiting the latency, or it has a negative impact, I would say, on latency of autonomous system because it has to wait until the answer comes back. It has an impact on the security because the data has to go backwards and forwards and backwards and forwards. It has an impact on the energy consumption because data, as I mentioned before, is requesting energy to move from left to the right. Also, the big environments consume a lot of data. So this is why we are now going more and more to a decentralized environment. Decentralized environments mean that we are going to leave the data where it is. And we're going to find new algorithms that can work in a decentralized way and move away from that one cloud-only platform. You will see a lot of involvements there, and I think my vision is that Europe has definitely a role to play. Now, this is very technical, and it's very much linked to what our human body is doing naturally. And there's one more example in that domain. Our human body, as I mentioned, is very good in making sure that the sensors that we have intra our body, they're working together very autonomously. From when we are born, we don't have to make sure that our eyes are linked to our ears and linked to our mouth. This goes automatically. Now, this is not the case in the systems we're building. And a very easy example is a recent accident that happened with Tesla, where there was a very bright day, sky was white, there was a truck that was turned over on the motorway, the top roof was also white, so the camera from the Tesla didn't see the difference. It looked at the picture and it didn't see the difference between the white of the sky and the white of the truck. However, the radar detected the truck, but what happened is because these sensors are working independently from each other, they send back that information to the car center, and there's a conflict because the car center gets the information while there's something and there's not something, and then it decides by a human rule that says, well, if it's daylight, it is the camera that gets advantage because we know that the radar from time to time has a mistake in its decisioning. So we give the the image camera advantage to the decision because it is a full daylight. However, as we could see in the press, this accident happened because what needs to be done what we need to do, we actually need to work like our human body works. That means that we need to be able to fuse that information right from the start. So not make these sensors decide independently, but fuse the data right from the start. As you can see here on the right side, you see that these bicycles are detected much faster when you fuse the data right from the start and you have an inter-device algorithm instead of the bike that you see to the left. You will get the slides at the end, so you can review that example. But this is a domain we're very much looking forward to, and that will be tremendously efforts for all autonomous vehicles out there. You know, sensor fusion is a very hot topic. Now, sensor fusion, again, is something that we do from nature when we are born. Next to nature, we also have a lot of things that we learn by growing up, by education. We learn how to communicate with other people. We learn, to apply reasoning to certain decisions. We learn how to, put ourselves in the theory of mind. We learn how to collaborate with other people. Now, all these things are also still lacking at the moment in AI. In fact, they're not completely lacking. They're just not yet combined. This was also shown by Luc this morning, that when we talk about AI right now in the press, we talk a lot about data systems, data-driven systems, but we also have reasoning systems. We have systems that can have a memory, etc. But however, at the moment, all of them are developed separately from each other and not yet combined. That means that at the moment, our standard AI systems, our data-driven systems, are actually lacking common sense, just like we as a human have. If we train a system on what it is to be a chair, and we show a chair of 4 legs, we as a human, we immediately understand with common sense that even if a picture has, or an object has 3 legs or 5 legs, it's a chair and we can sit on it. For AI, we need to train a lot of examples showing chairs with 5 legs, with 4 legs, with 6 legs, and each time saying, this is a chair, this is a chair, this is a chair, this is a chair, because AI just lacks this common sense to make that link itself. I'll just skip that slide, but similar, next to the concept, it also lacks abstraction. Abstraction, here what you see, and ask a child of 4-year-old from where is the real snowman, he will easily say it's on the 2nd and the 4th picture. However, if you would be an AI image recognition systems that looks at the picture and then the different pixels out here, it is very difficult to understand that difference. However, that means that if you would be a camera and you need to decide at what point in time to stop next to the road and you can't make that difference, you don't know that the 3rd one is a child and the 2nd one is in fact a snowman that will never cross the road. So it's a danger that pops up that we try to encounter by adding more sensors. We will add, for example, an infrared sensor to detect the warmth, and we see, that picture number 1 and number 3 are living beings with a certain heat. So this is because AI at the moment cannot yet make that abstraction like we do naturally as a human. To prove my point, and where we need to help AI systems to understand that and helping that, making that abstraction, you can see it when we have to fill out the CAPTCHAs. The CAPTCHAs is nothing else than images taken by Google, where there's some confusion by the AI system on what is, for example, a real road sign, what's a real traffic light. If you look at the example left, you see on that green truck, you see a sign in green and white letters, but just above we see a road sign in green and white letters. So for AI, it's very difficult to understand what's now a road sign and what's just a sign on a truck. Or to the right, we see the traffic lights, or we also have these crossings. And I think we all have come across these examples when we're trying to access a website where it tells us, I want to know if you're a robot. Well, I'll tell you, there's many other ways you can find out that's not a robot behind the laptop. But these are just ways where Google relies on human support to get that abstraction layer into the pictures that we have in order to understand the complex world we're living in, because AI by itself cannot make that abstraction layer. The next one in line is the intra-device algorithms. We are now very good in creating autonomous systems that are good in, for example, getting better and better in collaborating with people. But what we've noticed is that these systems have never been trained to environments where they will meet each other. So one autonomous vehicle meets an autonomous robot, for example, in this bizarre collision. In Las Vegas, by the way, on the most impressive show that you can imagine on autonomous systems. And what you see is that none of them, nor the robot had seen the car, nor the car had seen the robot, and a collision happened. And so that means, because there's still a lack of standards of communications, and also the complexity of the future world we're going to be in, where there's more and more autonomous systems that are going to be out there, we haven't gotten to the needs that we have in order to make sure that everything happens safely. For example, for me, what I always observe is that from a legal point of view, we're now putting rules in place for who is going to be responsible when we have an autonomous environment, which causes an accident with a person out there. But we are definitely not ready to create these legal environments when there's one autonomous system meeting another autonomous system. So it's something to think about. Now, when I continue that line, so these are all still limitations of AI. If we want to, look for success in the future, these are things that we need to solve. Another point, if you remember my first slide, is I went actually pretty quick on that slide. I said, well, we take data, we crunch it, we analyze it, and we make a decision. Well, no, what we do in the middle, with our frontal cortex, we are going to do some reasoning on the things we've seen. Well, this reasoning layer is completely lacking at the moment in AI. And an easy way to show this is by an example we've done in our labs, where we train the system on a simple list of calculations like 3 + 4, 5 + 1, 6 + 1, etc. And we needed about 30,000 examples of calculations underneath 10. And in fact, there were 60,000 iterations in order to get to an accuracy of 85. Well, asking a 6-year-old child at the first grade school, he will be able to solve that. Now, what we noticed is that the reason why is that because a logical operator like plus is not recognized as a logical operator, it's just like recognized as pixels. So if we take out that logical operator and we just train the system on the recognizing the tree and the force and the numbers underneath 10, after 300 examples, we get to an accuracy of 99%. That means that finding systems that can combine one side image like data recognitions and the other side logic is going to be very important towards the future in order to limit the complexity that we sometimes build in our systems right now. On the right side, you see another fun way of explaining this is you see 2 pictures of dogs. Of course, the AI can recognize the dogs. It will tell you one picture has 3 dogs, the other picture has 7 dogs. But if you ask that very same AI system, which picture has the most dogs, most again is a logical question. Well, it won't be able to answer you. And this is a limitation that's not very often seen. Another limitation is that, or even error that's sometimes found back in industry, is the fact that we sometimes tend to be too fast. And when we see a correlation in data, we quickly call it a causality. And a funny way to see this was the COVID-19 found in toilet paper. They saw the numbers of COVID-19 were going up, and then they also saw that toilet paper was sold more oftenly, and they made a wrong correlation. Of course, this is a fun way of saying it. However, if you think about what happened this week, also indeed, is it a correlation or is it a causation? AI at the moment is not able to look at causations. It's something we really strongly work on right now from a research perspective in order to make sure that the AI system can go past that stage of correlations and can also see causations. Next in line is the fact that our AI systems, commercial systems out there, they're very well trained in one context, but if that context changes and our world has changed, we see that these AI systems start to fail. I noticed from talking to business people that they don't always understand that this context importance, the fact that the changing context also means that you have to put processes around your AI model in order to make sure that the changing context can be tackled and can be observed and can be adopted. Some very easy, understandable something for a data scientist is for business not always yet understood. And this is basically just some examples of where I think that it's just the way AI works at the moment. Some limitations of the ability that we have now in the systems we've created. Some things that we need to know. However, the second part that I want to talk right now are different type of examples. These are the examples where it's not the AI that has limitation, it's actually people that haven't really quite understood how it works, which causes errors. Let me just show you 3 examples on this. Now, the way I look at it, because these are examples that are now mainly done cause issues in business. I noticed that business doesn't always understand that implementing AI is in fact more than just having data or hiring a data scientist. It's in fact a huge process where different people with different roles are involved, and where it's not the data that's the trigger, but it's the fact that you're going to solve a challenge. So the way Kasi Kosirka from Google translates it is she always compares it to running a restaurant. When you run a restaurant, you are not just going to install a restaurant. You're first going to analyze the challenge. You're going to analyze the market you're in, the potential customers you have, the competition you have. And from this, you're going to decide to select a certain restaurant, let's say pizzeria. Once you have decided that, you're going to decide which ingredients you need. You're going to decide which appliances you need. You're going to hire a cook. You're going to get the best recipes. You're going to create the dishes and then bring them to your customer. So you need people that can bring them to the customer and get that feedback back from the customer saying how they like the pizza. When you explain it like this, that easy for a restaurant, which everybody understands, and then you compare it to a decisioning system or an AI-driven system, you can actually say that the ingredients are basically the data. Your algorithm is basically the different appliances that you can use, because we have different types of algorithms for different types of solutions. You have your data scientist, which is basically the cook. You have also things like, once the decision is made, you need, a way to bring it to the customer, but also bring back that feedback loop. You don't leave an automated decision out there. You're going to look at the fact that your automated decision has the impact like you wanted it, based or triggered by the challenge you've defined. Now, anything that can go wrong in a restaurant can go wrong here in your data science. So compared to the fact that if you tell me, Mieke, I have a lot of ingredients, you must be able to cook something. Yes, I will be able to cook something, but it won't be the best driving restaurant or best running restaurant. That's very similar to data. Having data by itself is a cost. It's not a profit. You need to understand the challenge, and then from there you start detecting the data that you need for this. Or saying to me, Mieke, I have a data scientist, I'm all set, is saying like I have hired a cook. Well, I always make the joke, but Sergio Heijmans will not cut the vegetables. Don't let your data scientist cut the vegetables, or let's say prepare the data. He wants to model, he wants to create models. That's what he likes to do, that's what gives him energy. So don't put him 80% of his time on cleaning up the data that he needs. He doesn't like cutting the vegetables. Similar to the fact that people don't like, looking at the feedback loop. Mieke, we're too busy. We're just operational. We don't have time to look at the feedback loop. Well, that's just the same as just like throwing your pizza in the restaurant. Don't worry about what the customers say. You don't do this. You don't do this in AI. You don't do this in a restaurant. I have people telling me, Mieke, you're going to be happy. I bought a model overseas because I couldn't find any data scientists in Belgium, so I bought a model overseas, and I'm just using that one. That's the same as saying, well, Mieke, I'm just heating up a Dr. Utke pizza. You don't know what ingredients are in there. You don't know what quality it is. You don't know where it was created. But it's the same. So you need to go a little bit deeper in your knowledge, understanding this whole. And that's an easy way to re-question yourself the way you do AI. Now, if you dive deeper into it, what else can go wrong? As I mentioned, I was going to use 3 examples. Well, sometimes data scientists work in a silo, not understanding very well where their solution is going to be implemented. This was a solution created in New Zealand, where the data scientists didn't know that was actually going to be used for an airport, to decide if an airport was going to leave people in or leave people out. And so, of course, the data that was used for training that completely missed the context where it was going to be installed. This is a human error. This is just a matter of getting used the right training data for the context where it's going to be implemented. Another one is not understanding very well the techniques you've selected. Like in our kitchen, again, we are going to use certain techniques that have all their own limitations. This is Microsoft with their Thai chatbot that was using reinforcement learning. There was no human in the loop. So that means they just let the system decide from the feedback from the last question, trade itself to give the next answer. Without putting human in the loop, it quickly understood how to start talking propaganda for Hitler, because somebody decided, or actually a group of people decided to give on every question the answer, Hitler was great, Hitler was great, Hitler was great. So after 5 minutes, Microsoft had to take it offline because Pi just thought that this is the way we talk. Now we talk about Hitler as being something great. So not putting human in the loop in certain ways you select your technologies for your AI systems is just a danger. Next but not least, this is a point that was already highlighted a lot. You could imagine that this 5 or 10 years ago that we don't know that unconscious bias is entering our systems. Well, it still happens in 2020. This was middle of COVID crisis where students in UK couldn't make exams, and so they decided to divide the A grades and the grades to the people, to the students based on historical data, which of course was not acceptable because it was full of bias. So it's still happening today, and it's very weird because there's been quite a lot of attention on it. But so these are all human errors. And so if you want to look at success metrics, what it means, you basically need to make sure that you're trained. If you're gonna, as a company, if you're as a business going to implicate AI in your processes, or you're going to apply AI into solutions you're building, get yourself completely aware of the processes and the needs that are around it in order to avoid these type of errors. Now, last but not least, I also talk to you about the ugly. The ugly ones are not the limitations of humans, or humans that are having a good say attitude. It's not the limitation of the technology, because the technology is worked. It's just that the framework we having right now out there, or the environment we have out there right now, is permitting things that shouldn't be permitted. I compare to the when we back in 1950s or 1960s, when we went to the North Sea with our car, we were just driving very, very, very fast on that motorway, and there was no traffic signs, there were no traffic lights, there was no driver's license needed, there was no police, there was hardly anything, but we were just going fast on that motorway. So there was no framework in there to do it safely. Well, at the moment, AI is not yet, hasn't been able to work in a very safe environment, and that's something more towards government, the request to government to make sure that our data scientists can create solutions, our business can use solutions in a very safe environment. Let me show you what I mean. It also starts with some innocence in a lab. Some engineers that find out yet again a new type of algorithms, generative algorithm, for example, and it's all fun. It is very innocent. It's very maybe sometimes naive out there, and we all love it. I mean, this is the Make Me Zombie application, and this weekend there was another application of making fake movies that make you dance. Very fun. We all love it. However, we don't always realize the implications of these algorithms and the fact that they are that open out there on the market. Similar to the algorithms that we have out there on language, the fact that we can now automatically write books by just training a system that reads a lot of Harry Potter books. The last Harry Potter book was written by an algorithm. It's only 7 pages. And just like the article in the Standard this week, you can still see as a human that it's not very perfect. However, it's one of the biggest concerns of Amazon right now, that they no longer know the books that they have and that they're selling on their platform, which one are written by humans and which one are written by algorithms. These are free algorithms that are available to everybody, that are now also being used for chatbots, for fake news, so which is slightly entering the danger zone. Let me give you 2 more examples. These are examples from a Canadian university and then from, I think, a UK university, where it is possible to type in any text. And then it was initially created for people that are disabled and that want to have their text back in own handwriting. Well, now you can type any text and you can say, well, give me this text in this type of handwriting, and you will get this text. But what if you upload what if you select your doctor's writing, or what if you select your parents' writing for these are dangers out there that always start from an innocent point of view, but if you think about it further, you wonder if it should be that open, that algorithm, similar to the algorithm that was created again from a very positive point of view for people that are deaf. So if they watch any type of movie, the text is typed automatically underneath it. So by recognizing the lip movements with 93% accuracy, this algorithm, which is open to everybody, can now put out the text. But what if this comes in hands of people that have different IDs with it? It means that basically any video that you have without sound, you can now know with 93% accuracy what is actually said in that conversation, which makes you think if it should be that open. And I think that the worst is still to come. The fact that these algorithms are completely open and are now used also, very similar algorithms than the one that I've just mentioned, to actually change, for example, images, medical images in this case, in order to get a priority on for example, an operation. Yeah, the security by design fact, to limit access to certain type of algorithms hasn't been well thought of. So I think for me, cybersecurity and security as a whole, as a topic, should be combined more and more with AI. This is not the case. I'm finishing off my presentation because what I'm looking for is more human AI translators. This is also the request in my book. It's also the title that I have in my English version of my book. What do these human AI translators need to do? Well, they need to be able to understand these three differences, good, bad, and ugly. Understand that we are still in an area where we have narrow AI, we're moving towards broad AI. We are not in general AI, we need to decrease that perception that is out there in the citizens. Second thing is these human AI translators need to understand how much human involvement is needed in automated decisions. I need to, coach companies or coach people on the fact that based on context, impact, results, or objectives, you need to define how much human involvement should be in there. Don't leave a system out there by itself. So you look at and you analyze the context of where the system is going to be installed. And last but not least, it's also the task of the human translators that they make sure that everybody in the loop, if it's developer, or it's the customer, or if it's the government, they are able to take away that complexity bias from that hidden little tiny algorithm that's somewhere in an autonomous system, but that needs to make decisions out there. I compare it to the fact that if we eat our food or we eat our medication, we get this leaflet out there. I am absolutely supporting the idea of having a leaflet, or like at least a text supporting our autonomous system, saying the limitations, how to use, what to do when it goes wrong, etc. I would like to thank you very much for for listening into this presentation. You need to know that all copyright income of this book is going to Dwango. Dwango is an organization that won the Queen Fabiola Prize, the Queen Paola Prize for innovative solutions for schools. They're focusing a lot on AI, and all their material they're creating for schools is really available from their website. Thank you very much.
Thank you so much, Mieke. Thank you. So we have some questions from the audience. Mm-hmm. One question from Alexander Vika, who support all the week with Casper and Benjamin and some people from many organizations, in fact, but they are working with BOSA. And he has a question for you, because he saw that there is an article published in L'Echo this morning. And can you elaborate on your proposal for the introduction of an AI energy label?
Okay, yeah. So at the moment, was somewhere mentioned in my presentation. So at the moment, we all look at accuracy. All papers are compared to each other with accuracy. Whereas when we look at other technologies in our life, just like the white products, the washing machines we're using, or the cars we're using, we've passed that stage that than just looking at accuracy. We've passed that stage, and we've included energy labels in there. Well, exactly the same should happen to AI. We should not strive for that accuracy, but find a balance between accuracy and energy efficiency. And by having that label, we force developers to make sure that they look at that part of the system as well. By, again, as I mentioned it before, getting ourselves inspired by the way we do it in nature. it's not because technological we have the ability to do something. It's not because the systems are there or the cloud systems are out there to do something that we shouldn't be critical to ourselves to look at the energy consumption of our AI systems. And again, asking Siri what weather it's going to be tomorrow, it's about 12 grams CO2 emission. Well, think about it if this is the right use of our technology.
Yeah, there is a question from Sarah Boremans. She sees that now when she's writing in Teams in Dutch, Teams ask her, okay, are you writing in Dutch? And okay, she is a bit okay, wondering what it can induce. And what do you think of this example?
Not completely sure what she's after, but is the question, is it how it is detected automatically, or
no, she says, personally, I imagine not all users will be so open to help improve the AI algorithm.
Yeah, no, and I agree, but I think sometimes companies still think about the fact, and that's where I want to have more transparency of companies. We are training far too much big environments without knowing it. That was the case with Facebook. We were tagging ourselves in Facebook images, and now Facebook can recognize ourselves. If we are calling call centers and it says, well, this call can be taped for training, well, I tell you, it's not for human training, it's for training an AI system out there. So, but the fact that we don't always have a choice to get past a certain stage to say, well, we want to participate in training these systems or not, is for me an error. We should have the ability, for each person individually, to decide it case by case. So I agree with her there. So privacy, or I mean, it's slightly linked to privacy, but privacy is a right of everybody and every individual, and we don't get the right. We're sometimes forced to use a certain system or forced to do something in a way that a company wants it to make money afterwards.
Thank you, Mieke. There are many questions coming, but I'm afraid we won't have the time to answer them because we have to go to the next session. Do you know what we have in the next session?
It's going to be my favorite session, even. It's one domain I don't dare to look into much depth is design, art, and the combination with AI. And as I mentioned in my book, I'm looking forward to going on retirement to get more time for this, because that seems absolutely passionate. So yeah, this is going to be Anouk Wieprecht, who's is a fantastic lady. When we met her Saturday, or you've known her for a long time, but I met her like Saturday 3 weeks ago, and I found a lady having the same passions as myself. Same controllers to sensors to science, and then combined with fashion. It's fantastic. I'm very much looking forward to moderating that session.
So we will go. Do you want to moderate this session?
I'm going to moderate that session. Yeah, I prepared my questions.
That's so great. Thank you, Mieke. And let's go to the next session with Anouk Wieprecht.